So in this video, we're going to talk about no solution and infinite solution when you're solving multi-step equations, in addition to problems that do have a solution, so you can see the difference. Now, let's talk about the no solution example that we have here. We know the answer is no solution, but I want you to see what it looks like. We still start by the same steps that we've learned before, where you distribute first if that's needed. So we have negative 8x minus 4 equals negative 8x minus 2. Now remember, we always want to eliminate the variable on the left-hand side. So to eliminate negative 8x, I'm going to add 8x to both sides in our like term columns. Well, don't freak out. Notice all the variables eliminate. And that's okay, you're just left with, I'm not even going to worry about the constants right now, negative 4 equals negative 2. Well, now that all the variables have eliminated, we basically are left with a question. Is this a true or a false statement? So again, I always want you to ask yourself this question. When the variables eliminate, I want you to ask, is it a true or false statement? Well, negative 4 we know does not equal negative 2, so we know this is false. So I'm going to say that there's no solution. And we use this symbol, a 0 with a line through it. It's different than a 0. This actually means empty set. So up here at the top, you could say this means empty set, which basically means no solution. It's just faster to write this symbol rather than the words no solution. And frankly, you're going to see it in Algebra 2 and pre-calc and everything else quite a bit. Now let's talk about what an infinite solution question looks like. Well, if you notice on the left-hand side, there's nothing, we can't combine these terms, but on the right-hand side, we have some simplifying to do. And again, simplifying just means, is there any distributing and combining like terms? Well, we do have to distribute the 3, so I'm going to copy the right-hand side, nothing changes there. But then 3 times 1 is 3, and 3 times minus 3x is negative 9x. And then that minus 8 we just copy because there's nothing left to do. But on the left-hand side, or sorry, the right-hand side, we can combine the positive 3 and the negative 8. So we get negative 5, just negative 5 minus 9x equals, and I always put the variable term first on each side, so negative 9x, and then this becomes negative 5. Well, there's two things. First of all, both sides are completely matched. That's one indicator of infinite solutions. The other way, if you forget to check that, if I eliminate the variable on the right-hand side, I'm going to add the 9x to both sides. So we know that negative 9x and 9x eliminate, and again, they eliminate on both sides. Now, I'm not going to worry about the constants because I'm left with negative 5 equals negative 5. Well, again, remember what I said when your variables eliminate? In fact, let's just add, when the variables completely eliminate, the question you're going to ask, I want you to ask yourself, is it a true or false statement that's left? So is it true that negative 5 equals negative 5? Well, yeah, when is it true? It's always true. So because it's true, this is when your infinite solution situation works. In other words, I could plug in any number from x, and it'll always be true. And I always use the infinity symbol because, again, it's easier for me to write symbols than it is to write infinite solutions. Okay, so now let's look at some examples. So number 1, we distribute the 3. So we get 6x plus 6 minus 3x equals 6 plus 3x. I still have to combine like terms on the left-hand side. So I get 3x plus 6 equals 6 plus 3x. Now, I do notice that both sides 3x plus 6 is the same as 6 plus 3x because addition is commutative. Or if you don't remember that, let's eliminate the 3x, so let's subtract 3x on both sides. And as soon as you do that, you notice, oh wow, all the variables eliminated. So because this is happening, I'm going to ask, are we left with a true or false statement? So 6 equals 6. Is that true or false? Well, it's true because it's always true. We know that any number will work for x, and that's why we have infinite solutions. So for number 2, we distribute on both sides, in fact. So we get 12x minus 36 equals 14x minus 28. Again, don't forget to multiply your signs. So I'm going to go ahead and subtract. I'm going to eliminate the 14x, so I'm going to subtract 14x. Now notice they do not eliminate on the left-hand side. That's okay. We just keep solving like our previous lessons. So that means I need to eliminate my constant term over here. Whereas over here, since both variable terms eliminated on both sides, I didn't have to solve anything more. I just needed to check to see if it's true or false statement. But because the variables did not eliminate on the left-hand side, I'm going to go ahead and eliminate the constant term like I've been doing in all the previous multi-step equations. So then I end up getting negative 2x equals 12. I'm sorry, not 12. 8. Negative 28 plus 36, there's more positives, and there's 8 more positives. And then I just divide by negative 2, and x equals negative 4. So I just wanted you to see a situation of the previous, that's similar to all the previous equations we've already done, where the variables don't eliminate. So if the variables do not eliminate, you're going to get one single solution. There's no way it could be no solution or infinite solution. Those two only work when all the variables completely eliminate. So if you look at number 3, I'm going to distribute on both sides. So you get 40x minus 24 equals negative 18x minus 24. I'm going to add the 18x to eliminate on the right-hand side. And notice they're not going to eliminate. So I'm going to go ahead and add 24. Now, okay, actually the constant terms eliminate on both sides. Again, don't freak out. Keep going. Well, 48x plus 18x is 58x equals, well, let me ask you this. What's negative 24 plus 24? Isn't that 0? Well, let's keep going. Divide by 58. Now, 58 divided by 58, you get a 1x. 0 divided by 58 is 0. The point of this example is to show you that 0 can be your one solution. But 0 is not the same thing as a no solution. Because remember, no solution was when all the variables eliminated. Our variables didn't eliminate. And we were left with a false statement. We had something like 58x equals 0. We can still solve. And just remember, 0 out of something equals 0. 0 divided by something is 0. Now, don't confuse that with a situation like, for example, if I had 12 over 0, this is undefined. Okay? Don't confuse, so basically, if you have 0 in the denominator, you can think of it like 0 can't hold up any other number. 0 is not strong enough to hold up 12, or you can think of it like if I ate 12 pieces of candy, if there was 0 possible, or 0 available, I cannot eat 12 pieces of candy when there are 0 possible pieces of candy available. But over here, I can eat 0 pieces of candy when there's 58 pieces of candy available. Maybe I'm on a diet. Maybe I don't want to eat sugar. But that means the total I ate was 0. But this is not even possible, okay? So don't confuse these. It's okay to have 0 in the numerator, it just equals 0. But if you have 0 in the denominator, that's where it's undefined. And we'll talk more about that, especially when we get into slopes, vertical slopes. Now look at number 4. Okay, it might look like it's a really hard problem. All I start with is, oh, the left-hand side, there's nothing to do, so I'm just going to copy 3x minus 13. And then notice I'm just going to distribute twice on the right-hand side. And don't forget to distribute that negative 4 to both terms. So I have 7x plus 14, and then this becomes minus 4x plus 28, because negative 4 times negative 7 is positive 28. Now I still have to do some simplifying. I have to combine the 7x and the negative 4x on the right-hand side, and the 14 and the 28. There's still nothing I can do on the left-hand side, so I'm just going to copy. So it's 3x minus 13 equals, well, 7x minus 4x is 3x, and 14 plus 28 is going to be, let's see, 42. Now, let's just keep solving like we're used to. And as you know, we always eliminate the variable on the right-hand side. To eliminate a positive 3x, I need a negative 3x. So if I have the negative 3x on both sides, this time both variable terms eliminate. Remember, this comes back to this question. Now we just see, well, what's left? I have negative 13 equals 42. Well, is that a true or false statement? Well, you and I both know that negative 13 cannot equal 42, so this is false. And basically, the final answer is just no solution. Okay? And we will be checking these situations in class, or more of these equations in class. So bring any questions for clarification that you may have.